We're looking at substitution today. What is substitution? Why is it important, right? Let's just quickly remember, algebra, we said it's this relatively new, historically speaking, relatively new kind of maths, and I called it a game changer, right? It's this new ideas way of approaching things that allows you to solve and approach all different kinds of problems, right? Do you remember the key idea? The key idea in algebra is, well, how would you express it? What's the key idea? Yeah, Nathan.
Putting similar things together.
Yeah, good. So we had some words for these, by the way, as well. One of them is, for example, pronumerals, right? So we tend to use letters to indicate numbers that we don't know. Numbers that we don't know. So not only are they called pronumerals, they're sometimes called variables because they can vary, they can change. Another name, which I sort of said but I didn't write down, which you can write down now, is unknowns. Right? They're numbers and it's like, I don't know what they are, but I can still work with them. Okay? So if this is the key idea, right, you can work with numbers before you know what they are, then this is how you kind of will take that idea and now put some like real numbers into it, right? So substitution simply means it's a word for, well actually, can you give me a synonym for substitution or substitute? Instead of saying, I'm going to substitute this for that, what other word could you put in there? Any suggestions? Yeah, Jordan. Swap. Wonderful. Substitution is swapping. Any other suggestions? Yeah. Replacing. Also, perfect. Right? It's the idea of taking something else and putting something in its place. In fact, that's exactly what replacing means. Okay? So here's an example, right? We've got all of these expressions here, and if we can replace the pronumerals with the values that they're meant to stand for, then we'll have done a substitution, okay? So this is the way I'd like you to set it out. This is the way I do it, right? Where you get given pronumerals and you get told what they are, and this happens in real life and in tests all the time, I often like to write down what they each are. I have them all laid out in order. And then when I have these things here, I'll put down a little bit of working to make sure I do the substitution right. Okay. So even though I can look at this and then look at that, and I could straight away say that the answer is 8. The answer is 8. I'm going to go through and put these just 2 extra lines of working to show how I got that. Here's the first one. What's the actual question? Okay. And then I just want to substitute one at a time. What should I write? Yeah.
Is it A, B, or is it
So it's A plus B. A plus B.
Yeah, but is it answer 8, A, B, or just 8?
Sure, okay, well, that'll become clear as we write this down, right? So what I'm going to do is, I'm going to take these numbers, and you don't have to write this bit, but I'm going to replace them, right? I'm going to swap them out, right? So instead of A, I'll write 3. And instead of B, I'll write 5. So that step there, that's the substitution step. Now we've started off with really simple stuff you could do in your head, but it's going to fairly rapidly go to stuff that you don't want to do in your head, and you want to write down this step. This step is called the substitution step. Right? It's literally the point where you just take all the numbers, all the right values, and you put them in the right spots. Now I can evaluate it. That's equal to 8. Okay? So, now that we have the basic idea, I think we can jet through the rest of these quite quickly, right? For A, what will be my substitution step? What should I write down?
4 times.
I should write 4 times 3, right? So you notice with algebra, you can just get away with saying 4A. But when you've got numbers in there, you can't just write 4, 3, because that means something else different, doesn't it? So it really does mean 4 times 3, which is 12. Okay, someone else, William, what should I write for this step?
6.
Someone help him out? Yeah, Brandon. 2 times 2. I can write 2 times 2, or just as equally, because it's the same. I can write 2 squared, they're both equivalent, which is 4.
Minus 2 times 2.
Great. Okay, so that was already the next question we were looking at. And it's really important. You can see it's starting to put in more things together, and the operations are going to start to get a bit trickier here, right? You don't have to, but you may like to help yourself clarify what's going on by putting brackets. right? That will help you remember what you should do first and in what order, okay? So that's going to be 12 minus 4, which is 8. Okay, you could put down 12 minus 4 if you liked, but I think we can go straight to 8, and that's okay. Our last one here, 2a, that's 2 times 3, all divided by 2. So what's that equal to? You can do some cancelling here on the fractions, right? Yeah, Nathan. That's okay. Someone else want to have a try? So, yeah, Jonathan.
3.
Good, it's 3. And you can see that if you take this 2, you cancel it with that 2. All you're left with is 3. Okay? So you can see, like I keep saying, working really matters. This step, and so on. These are the most important steps in the working, and the final number is less important, okay? So that's a bit of start. As you go through the questions, you'll get more layers of complexity, but the basic idea is there. Okay?